If a computer wrote this sentence, how would you know? How about this video? Or this image? The line between AI made and reality gets thinner every week. But what is AI? Artificial intelligence is basically the endeavor to build systems that can perform tasks that normally require the human mind. For example, humans can reason, they can recognize things, and they can also make decisions. Under the artificial intelligence umbrella sits many disciplines, including machine learning that we talked about in this video, and also deep learning, to name a few. However, when people say AI today, they usually mean large language models. Think ChatGPT, DeepSeek, or Gemini. In this episode, we'll focus on LLMs to understand the technology that has reshaped tech. I like to use analogies to build mental models when I'm learning things. So here's the mental model for the rest of this video. Imagine a bustling newsroom inside a vast library. Tokens are the Lego bricks of language, words are reporters carrying notes, attention is deciding which reporters to listen to right now, the context window is the size of the whiteboard everyone can see, and sampling is how adventurous the editor feels when choosing the next word. Hold that picture in your mind as we dive into how LLMs actually learn. Large language models learn with a simple but powerful objective: predict the next token. A token is a small chunk of text, often a subword like inter plus national plus ization. So a sentence becomes a sequence of integers. Think of tokens as the Lego bricks of language, tiny pieces the model can snap together. We first tokenize text into these units. The model maps each token to a vector, an embedding, that captures meaning and context before predicting the token's next distribution. Now imagine the model as an apprentice author, learning to finish someone else's sentences. Each guess is graded, with cross-entropy loss, like a strict marker who penalizes a cocky wrong answer more than a hesitant one. After every grade, the apprentice rewrites. We nudge the model's dials with stochastic gradient descent, so the next guess is better. If gradient descent is walking downhill in fog, Adam W adds momentum, a push that keeps you moving in the right direction, and weight decay, a gentle pull back towards simplicity, so you don't overfit to noise. Because the right answers are just the next words in ordinary text. This first phase is self-supervised pre-training, like reading the world's library and playing autocomplete at every step to absorb style and common facts. After that library phase, we fine-tune the model with instructions, an etiquette class that teaches how to respond to prompts, and then align it with preferences like RLHF, RLAIF. Essentially, an editorial board with red pens giving feedback. More helpful, less risky. To check it hasn't merely crammed, we keep sealed chapters it never saw, the evaluation set. Perplexity is the model's surprise meter. Lower means fewer gasps at what comes next. Passing these tests tells us it generalizes rather than memorizes. Picture a noisy newsroom writing one sentence together. Each word wears 3 name badges: query, key, value. When the next word is about to be written, it looks around the room and asks, who should I listen to right now? That's self-attention. The current word, the query, compares itself with everyone else's badges, the keys, decides who matters most, and then blends those people's notes, the values, into its own thought. If you want the maths in a sentence, we take dot products to measure relevance, use a softmax to turn those into how loudly to listen, and then mix the values accordingly. Order still matters. For example, dog bites man isn't man bites dog. So we add positional encodings. Think of them as bar lines in music or page coordinates, gentle hints that keep words in the right order, even though attention can connect any 2 words. To capture different kinds of relationships at once, we use multi-head attention. It's like several editors reading the same sentence, one tracking grammar, another tracking topic, another tracking sentiment. We stack many layers of these editors. Each pass refines the draft a little more, So by the time you've had 10 or 20 passes, the model can translate, summarize, and even reason to a surprising degree. Under the hood, the model still does one humble job: predict the next token. Given the capital of France is, it assigns odds to candidates. Paris is high, others are low, and writes the next word. Do this repeatedly and you get sentences. How creative it feels depends on sampling. Tempera is the spice level. Higher equals more adventurous, while top P is a short list of likely words to choose from. Why are transformers everywhere? Scaling laws give them more data, more parameters, and more compute, and they keep getting better, though with diminishing returns and rising costs. However, we are seeing companies innovate to compensate the diminishing returns and rising costs. It's like hiring ever larger newsroom teams and building a bigger library. Quality improves, but each extra editor helps a bit less and the bill climbs. AI is exceptional at pattern recognition at scale, ranking feeds, detecting anomalies in finance or cybersecurity, reading medical scans, powering search, and generating drafts for code or content. Properly framed, it's a force multiplier. Faster triage, better retrieval, fewer keystrokes. But it does have its limitations. Hallucination is AI's gift for confident storytelling. Think of a supercharged autocomplete that would rather finish the sentence than admit it doesn't know. That's how we get fabricated citations in legal filings, wrong medical facts in demos, or a customer service bot inventing policy. Fixes turn the test into an open book exam. RAG pulls facts from trusted sources at answer time. We show citations, we calibrate with I don't know, and abstain when evidence is thin. And we evaluate with question sets that demand verifiable references. Brittleness and jailbreaks are social engineering for machines. Imagine a nightclub bouncer with house rules. A crafty guest sweet talks past them. Prompt injection is that sweet talk, sometimes hidden in a web page the model reads. Guardrails matter, but so do better objectives, rewarding truthfulness over engagement. Input sanitization, tool permissioning, and red team drills where we actively try to break the system before attackers do. Bias and fairness show up like a warped mirror. The model reflects patterns in data, including the ugly ones. That can mean different error rates across dialects or demographics. Data provenance and copyright is the who owns the library question. If you learn from a public library, what are you allowed to quote? The direction of travel is clearer datasets and licensing deals, plus content provenance tags. For example, cryptographic stamps in images and texts, and training disclosures so downstream users know what went in. Energy and cost. Picture a bakery with thousands of ovens. These are GPUs. Training a frontier model can run those ovens for weeks, serving millions of queries, keep them warm all day. The bill is real. Power, cooling, and hardware. Efficiency is a first-class feature. AI isn't magic. It's optimization at scale, with human choices baked into the objective.